once it starts. All right, messages are recorded. Okay, so if you don't want your message recorded, then don't type one in there right now. Hello, Deep. Okay, I'm going to present my screen here. And like I said, you guys are going to, you will need to write this on paper, okay? So I'm gonna try doing handwriting. I think it's a little bit easier than printing on here. So review of factoring and rationalizing. You don't know how much I practiced my handwriting when I first started teaching, and it was all actually on a chalkboard, and then on an overhead, and then on the Elmo, which was actually the easiest, and now on a tablet. Oh my, this is really hard for me. Okay, so bear with me, but I'm saying it as I'm writing it so you can hear it even if you can't read my horrible printing. Okay, factoring trinomials. And if you have a question, you'll have to call it out because, oh, I can see the chat. You can type a question in the chat, but I keep forgetting to look at it. And thanks, Anoop. My writing is amazing. Oh, wow. Okay, so factoring trinomials. And you all remember vocabulary, trinomials, like a tricycle means 3. So a trinomial, then when you're factoring trinomials, this is the order that you go in. Always start looking for a greatest common factor, GCF. Then, I think I used this terminology with you last year, IM trinomial, as in the leading coefficient is 1, what adds to the middle term and multiplies to the last term. And if that doesn't work, we have to do something that we nicknamed funky factoring, which is pull that leading coefficient out, multiply it by your last term, and try to factor and then bring it back. We'll talk about that in a moment. Okay, so I'm going to give you 3 quick examples. X squared minus 3x minus 18. And so when I'm factoring, the first thing I'm going to say is there a GCF? And there isn't. And so then I go to the next thing in my list, which is the leading coefficient 1? And it is. So now all I need to do is look for 2 things that add to -3 and multiply to -18. And I know you're all way faster than me and you've already thought of them. So to get the x, I need x times x. To get a negative here, to get a negative as for my constant term, one of these would have to be positive and one negative, because a positive times a negative gives me a negative. I want it to add to -3. I think you've all figured out that your 2 factors are 6 and 3. Because I want it negative, it's -6 and +3. And as usual, you always double check this in your head. I will write it out. This would give you an x squared, subtract 6x plus 3x, and then positive, negative, -18. And when I combine like terms, check, I do get -3x. Okay, so just to keep our notes a little bit neat, let me just write the factors there. So what were they? X plus 3 and x minus 6. Of course, though, you all did check it before you carried on. Okay, try this one. 2x squared minus x minus 1. No greatest common factor. The leading coefficient isn't 1. So what was that funky factoring I was talking about? Well, we take that leading coefficient and the constant term and we multiply them. Hold on, I'm just taking off all my bracelets because it keeps clunking on the screen. Sorry about that. Okay, so 2 times -1 gives me -2. And so I'm going to write this as hold on. I remember summer's been a lot. Summer was long for me too. I'm going to write this. I've got a -2, and my factor tree would be, oh my gosh, -2 and +1. Then look back at this leading coefficient, actually a simple example that seems harder than a hard one, and do this, okay? Then you reduce this fraction, it's -1, and this factor, because it's a fraction, becomes 2x + 1 and x - 1. Okay, honestly, I think I should have chosen a harder example, because the fact that this is easy means you probably did it in your head to start with. So check your work. You've got the 2x squared, subtract 2x and add an x. Check, I've got the -x, and a positive negative gives me the -1. Okay, when you did this as factor by grouping, then we would have taken this 2x squared and written -x - 1 and written it like this: 2x squared subtract 2x plus 1x minus 1. And so then these two terms, you can see, add up to that middle term. Okay, and then we factored by grouping, as in what's my GCF? Ooh. Fix my typo. 2x minus 1. What's my GCF? It's just 1. Oh my gosh. X minus 1. Good thing I have an eraser. There we go. Okay, and now I've got a GCF of x minus 1. It goes into the first term 2x and into the second term once. Okay, so I just showed you a couple of ways to factor that. Okay, here's my third example. If you have something like 3x to the fourth plus 7x cubed plus 2x squared. Do I have a GCF? Yes, I do. I have a GCF of x squared. Factor out the x squared, and we're left with 3x squared plus 7x plus 2. And does that factor? Of course it factors. You could factor by grouping, you could factor by guess and check, or you could factor by the method I was just describing, where you take the 3 and the 2, leading coefficient, and the constant term, and you multiply them together. And then you make up a factor tree. What multiplies to 6 and adds to 7? 6 times 1. Bring back the leading coefficient to both of those terms. That doesn't reduce. That does. So here are my 2 hints for getting my factors right there. What do I do with them? Don't forget that x squared is out front. Then 3x squared plus 7x plus 2 would factor as x plus 2 and 3x plus 1. Okay, so this 2 came from the pink right here. And the 3x plus 1, do you see how it came from my 1/3? Okay, so there's your funky factoring. You might want to do a little bit of review of that. And, ooh, I disconnected my keyboard. Now I don't know how to get an enter. Shoot. Oh, maybe I could add a new page. No, that's add a pen. Really, people, I'm so sorry. I'm not expert at this. I need to have made a couple of pages before I started. Hold on. I think I can reconnect this quickly. I think I got a new page there. Alrighty. So then our next, let me make a couple of new pages before I disconnect this again. Next week I'll be pro at this. Okay. All right, then next is we're going to just quickly remind you how to factor a difference of squares. Okay, so here's the pattern that we're always using. A squared minus b squared. And notice we said difference. That difference is referring to that negative sign. Okay, if it's a sum of squares, you can't factor it, so don't try. So remember how this factors? It factors as a plus b times a minus b. You can convince yourself that that's true simply by expanding this all out. A times a would give me a squared. A times negative b would be subtract ab. B times a would be plus ab. B times negative b would be subtract b squared. Collecting like terms, the positive and the negative, they cancel, and you left that with a squared minus b squared, just like what you started with. Okay, so then we take that pattern and we push it much further than you ever wanted to. So here are a few examples. Start easy. 4x squared minus 16. Remember, with all factoring, the first thing you look for is your GCF. And you can see you've got a GCF of 4, and this would factor as 4 times x squared minus 4. X squared minus 4 is a difference of two perfect squares. It factors as x plus 2, x minus 2, and it is completely factored. Let me make a little note here, because if you don't take out the difference of squares, and you look at that 4x squared minus 16, and you factor it like this, 2x minus 4, and 2x plus 4, you are correct, but you are not finished, because both of those brackets have a GCF in it. If you do this, and sometimes you forget the GCF first and you end up in this position, please do it correctly. You're factoring a 2 out of that first bracket. You're factoring a 2 out of that second bracket. Do you see that when you pull all the coefficients to the front, you end up in the same spot? It just took you longer to get there. What I want to make sure you don't do is just pull the 2 out once. You're actually needing to pull it out from both of the brackets. That's why this ends up being a 4 there, not a 2. Just a common error I've often seen. Okay, a second example. Why don't you give this one a try? 2x to the 4th minus 18x squared. And remember what I said, GCF first. So I'm going to drink some coffee and give you 2 minutes to do that yourself. And type the answer in on Google Classroom. In the stream. Hi, Karen. I see you're here. Oh, actually, I guess to make this easy so I don't have to switch back and forth, type your answer in on the Google Meet. In the chat. Okay, so you all started with a GCF of 2, x squared, the biggest common factor. It goes into here, x squared minus 9 times. There's your difference of two perfect squares. Don't forget this factor in the front, x plus 3 and x minus 3. Okay, next example is a little bit of a trick. X to the 4th minus 1. Difference of two perfect squares. Factors as x squared plus 1 and x squared minus 1, a little bit of a trick because you still have a difference of two perfect squares, so you're actually not done. X squared plus 1 doesn't factor, but x squared minus 1 factors as x plus 1, x minus 1. If you have questions, put them into the chat. And if you fill the chat up with hats, then I can't follow the conversation. Okay, so put meaningful things in there. Thank you, everyone. Okay, then let's move on to something fun and interesting. You might not have done this before. Factoring cubes. Okay, and I'm handwriting there just for a noob. Okay, so factoring cubes. So just a little comment. You know how you've got the quadratic formula? If you wanted to factor a quadratic equation, that is an equation of degree 2, you can always find the roots of the equation, that is the x-intercepts, which would lead you to the factors, by using the quadratic equation. That's not true of all polynomials. There are equations that exist for cubes, I think for fourths, maybe even for fifths, and after that they just aren't any formulas. And the formulas for 3s and 4s and 5s are just so incredibly complicated. I don't know if you even want to use them. But with a difference of cubes and a sum of cubes, we do have a pattern that will come out, and I'll show you what the pattern is. I'm not going to prove it to you. I think it might be in your textbook to look through. But we will verify that it works. So difference of cubes. Here's the pattern. If I have something like a cubed minus b cubed, it will factor this way. A minus b times a squared plus ab plus b squared. You are actually going to memorize that pattern and use it. I'll give you a little way to memorize it in a bit. But as I said, let's prove that this actually works. I'll do it on here and then I'll erase it. Okay, so if I were to FOIL this all out, that a would have to distribute to all of those terms. That would give me a cubed plus a squared b plus a b squared. When I distribute the negative b to all three terms, that would give me minus a squared b minus a b squared minus b cubed. And you can see that those would cancel, and you would be left with what you started with, a squared minus b, a cubed minus b cubed. Okay, so there's my little proof of it. Just going to erase that so I don't mess this all up. Sorry, that didn't go as easy as I thought it was going to. There's your difference of cubes. Here is your pattern for a sum of cubes. That is a cubed, oh boy, my writing is not so good, plus b cubed. This is going to factor as a plus b bracket a squared minus ab plus b squared. Okay, so let's really double check that we wrote this correctly, because you need to memorize it. You don't want to memorize something wrong. So a cubed minus b cubed equals bracket a minus b, close the brackets, bracket a squared plus ab plus, that's a b squared. A cubed plus b cubed, bracket a plus b, bracket a squared minus ab plus b squared. Okay, so I just use this little acronym SOP. Okay, so factoring cubes, SOP. Same, opposite, positive. Okay, so difference of cubes, the signs are the same. Okay, so there's the same. And then getting into the brackets, here we've got the signs are negative. The sign is the opposite, it's positive. And the last one is always positive. Okay, so here, a sum, the sign is the same, the sign is the opposite, the sign is positive. Okay, so there's your pattern for factoring. And let's do an example. Oops. Okay, so starting off easy peasy here. Pattern and following the pattern. Example A would be x cubed plus 27. So I have a sum of two perfect cubes. I'm following that pattern, a cubed plus b cubed. So it's like my x is my a and 3 is my b. This would factor as x plus 3 and x squared. So the sign was the same. The sign is the opposite. Minus 3x. The sign is positive. Plus 9. So stop and look at that. Do you know where I got the 3x and the 9 from? If not, type your question into chat. Okay, I'm going to give you one to try on your own. Would you give this a try? X cubed minus x cubed minus 8. Okay, just to give you a chance to practice. And when you're done, type the answer into chat. Okay, so just following the pattern then, are you getting this? Same sign, x minus 1, bracket, x squared, opposite sign. What is wrong? Oops, oops, oops. By which I meant to say x minus 2. X squared plus 2x, same, opposite, plus 4. Any questions there? Okay, then a question like this, x cubed minus 1. Then it factors as x minus 1, x squared plus x plus 1. Okay, going to make it a little bit harder. What about x to the 6th plus 8? Now you got to think about what's your a and what's your b. My x to the side, I could say here that my b is 2 because 2 cubed is 8. But what would I need to cube in order to get x to the 6th? Well, in fact, I would need to take x squared and cube it to get x to the 6th, because x squared all cubed means x squared times x squared times x squared. That's how I'm getting my x to the 6th. Okay, so if you look at my a and my b and follow the pattern for a sum of cubes, I want a plus b. Then I want my a to be squared. So if I take x squared and I square it, I get x to the 4th. Minus a times b minus 2x squared, and then plus my b squared plus 4. All right. Try this one. It's quite difficult. 8 x to the 6th minus 27y cubed. Okay, so do the same sort of a thing that I just did here. Decide what a and b should be, and then take it from there. Okay, I think it's easy to see that your b would be 3y, because 3y times 3y times 3y would give me the 27y cubed. For 8, if I were to cube, if I were to cube 2, I would get 8. What would I have to cube in order to get x to the 6th? I guess we just talked about this in our last example. So 2x squared. So now try to follow the pattern for your difference of cubes. We're using signs that are the same, signs that are the opposite, and the last one is positive. So 2x squared minus 3y and a squared, which would be 4x to the 4th plus ab, which would be 6x squared y, right? 2x squared times 3y, 6x squared y, plus my b squared, which would be 9y squared. Okay, if you want another example, you'll have to ask. That's all I've got at the moment. And then let's remind you of the factor theorem. Okay, so here is point 4, factor theorem. Okay, oh, this is so complicated to write. A polynomial, and we'll call that polynomial p of x. So the function p, which is the polynomial function, and the variable is x. A polynomial p of x has x minus b as a factor if and only if, and here's the abbreviation for that, IFF, if and only if, evaluating the polynomial at b gives you an answer of 0. Okay, so we did all kinds of work in this in Math 11 and especially in Math 12 in Unit 2 when we looked at factor theorems. So it's saying that if you put x was equal to b into the polynomial, you're going to end up with b minus b as one of your multiplying factors. And of course, it's going to give you 0, aka it's going to cross the x-axis. Okay, y is 0 if x is b. Okay, so we use that to factor things. So if we know the factor theorem and we have to factor this polynomial, 2x cubed minus 5x squared minus 4x plus 3. Then in order to factor that, we want to find a value of x that would make this 0. That's how we find our factor. And remember that they have to come from the factors of your constant term. So you're going to test the factors plus or minus 1 and plus or minus 3. And so that is, if the polynomial at 1 were equal to 0, you would know that x minus 1 was a factor. So if I let x equal 1, I'd get 2 times 1 cubed minus 5 times 1 squared minus 4 times 1 plus 3, which would give me 2 minus 5 minus 4 plus 3, which would give me what? Negative 9, negative 7, negative 4. Which does not equal 0. Therefore, 1 is not a root. And x minus 1 is not a factor. And you have to keep on testing until you find one. So then you test the polynomial at -1. That would give you 2 times -1 cubed. I'm not going to show you all the substitution. I think you understand. It's just going to make that number negative. Subtract 5 times -1 squared. Subtract 4 times -1 plus 3. So I hope you're understanding that all I've done is taken the x here and I've substituted -1 in for the x, okay? And so what does this add to? -2 minus 5 gives me -7 plus 4 plus 3. That does give me 0. And once I know that it's 0, I know that -1 is a root and x plus 1. So therefore, x plus 1 is a factor. This is where I wish I saw your smiling faces in front of me, all saying, oh, yeah, we remember this. It's a lot to explain. Okay, so remember our shortcut for doing this? We use synthetic division. Let me give you a quick reminder of it. So look here at this polynomial, and I'm going to help you remember synthetic division. Okay, so you write down the coefficients, 2, -5, -4, +3. Remember, you had looked at all of these powers of x. It has to be descending powers of x. If one of them were missing, you'd have to put a 0 in somewhere on this list. Okay, and we were looking at, oops, I didn't leave a big enough space here for myself. Okay, we're looking at testing the root -1. So we put the root here. Okay, so this is the root of the equation, the place where it crosses the x-axis. Okay, remember synthetic division. Start by bringing down the 2. Then you take this 2 and you multiply it by -1, like so. You add these together and you get -7. You take the -7 and you multiply it by -1 and you get +7. You write it there. You add these together. -4 plus 7 gives me 3. 3 times -1 gives me -3. Add these together, I get 0. Okay, how do we interpret this? Is that this last term is always the remainder. If the remainder is 0, you know that you found the root. This will always be the constant term. This would be your x, the coefficient in front of the x. This will be the coefficient in front of the x squared. If it was longer, we keep on going up, x cubed, etc. Okay, how do we interpret this? Well, we say if -1 is the root, x plus 1 is the factor. The other factor is 2x squared minus 7x plus 3. And you're not done, because now you have to factor that last term. So we've got x plus 1 times. And I'm going to do some funky factoring here. I'm looking at this 2 and this 3. 2 times 3 gives me 6. What multiplies to 6 and adds, oh my gosh, why can't I do this? And adds to -7. -1 and -6. Sorry, the sign was throwing me off there. Bring back your leading coefficient. This doesn't factor. It's going to give us 2x minus 1 as our factor. This doesn't reduce. This reduces to -3. X minus 3 is our other factor. You can double check and see that that would give you 2x squared, subtract 6x, subtract another x. We've got our middle term, negative, giving us the positive. Okay, but the point of this one was your factor theorem. Alrighty. Last but not, no, second to last. We're going to factor using exponent laws. Okay, so this is a little bit new. And probably the only place you're going to get a little bit lost on this lesson. So 2x to the power of 2/3 plus, fix this up. 2x to the power of 3/2 plus 4x to the power of 1/2 minus 6x to the power of negative 1/2. All right, when you're factoring, you are always removing the smallest common factor. So for example, I couldn't factor 4 out of these coefficients because it's too big for the 2, it's too big for the 6. All I can take out is a 2. So if you think about the coefficients, my factor is 2. And so, let me do this in 2 steps. I think maybe you'll understand it better. So if I took out a 2, I would have x to the 3/2 plus 2x to the 1/2 minus 3x to the negative 1/2. Okay, so far so good? Well, I'm going to tell you that you actually still have a common factor here. And that common factor is x to the power of minus 1/2, the lowest power. So if I take out the x to the minus 1/2 out of the very last term, I think it's easiest to see here, then I'm just going to have a minus 3 at the end. If I factor out an x to the minus 1/2 out of that term, I'm going to have a 2x. How come? Because this is like an x to the power of 1. Or I'm going to write it with a common denominator, x to the power of 2/2. You know what happens when you distribute this back? You're saying 2x to the minus 1/2 times 2x to the power of 1. So these would multiply and give me the 4. These would multiply, the bases are the same, and you're multiplying. Add the exponents. What is 1 plus negative 1/2? It is positive 1/2, and you're back to where you started up here. Okay, so keep that idea in mind. Oops, come on, eraser. My goodness. Okay, I got another way of doing this. My pen stopped working. Okay. So then what am I going to put here? When I took out the x to the 1/2, this is going to be x to the power of 2. How come? Because 2 plus negative 1/2 leaves me with 1.5 or 3/2. Okay, how else can I write this? Remember what a negative exponent means? It means it's in the denominator. All the rest of this x squared plus 2x minus 3, that's all in the numerator. I think we can see that my numerator factors x plus 3, x minus 1. And remember your exponent laws, x to the 1/2 means the square root of x. So this original question, which looked so complicated to begin with, 2x to the 3/2 plus 4x to the 1/2 minus 6x to the negative 1/2, simplifies to this. If you're working with it and you wanted to know where it's undefined, you're looking at your denominator. If you want to know where the zeros are, you can say it's at -3 and +1. All right, I will give you one more quick example of this, and then I'll do a quick review of rationalizing, which is actually fairly simple. So my last example here is 4 bracket x plus 3 to the 5/2. Subtract 2 bracket x plus 3 to the negative 1/2. Remember in Math 11, we did a whole pile of work on factoring by substitution? Well, this is the same idea. Substitution, think about your x plus 3 as being substituted by an a. You can see you've got a common factor of 2 on your coefficients. Your other common factor is x plus 3. Okay, it goes into the first term. The 2 goes into the 4 twice. My x plus 3, the lowest power appearing is negative 1/2. How many x plus 3s would I have left if I factored out a negative 1/2? Well, I would have them to the power of 3. How come? Because 3 minus 1/2 would give me 2.5. Well, 5 over 2 is 2.5. And then this would be subtract 2. Questions? Okay, you will probably come back and look at this example. You could be written this way. Oh, I see another GCF there of 2. So 2 over the square root of x plus 3. And then these second set of brackets have a GCF of 2. So pull out the 2, and you've got x plus 3 cubed minus 1. Sorry, like that. Which would simplify to 4 bracket x plus 3 cubed minus 1 all over the square root of x plus 3. I just see a mistake that I made. I hate this. Oh, good, my eraser works. I'm going to back it up all the way to there, because my mistake was right here. When I factored out the 2, 2 goes into this once. Okay, so this is 2 on the top, 2 times x plus 3 all cubed minus 1 all over the square root of x plus 3. All right, are you still here? We have one last, oh, I bet I could insert a new page. Oh, back to draw. Where did I see that? Oh, all right. Sorry, guys. Really, I'm going to get better. It's my goal. Okay, so let me get us another page here. Control, Enter. No. Wow. Okay, I'm going to do my last example right here, rationalizing. So quick reminder of how to rationalize. And we're actually going to end up rationalizing numerators more often than denominators in the next chapter. So let's remind ourselves of that. So rationalizing the numerator or the denominator, okay? So it involves multiplying by the conjugate. So remember what the conjugate is. And it comes from a difference of perfect squares. If you have the square root of a minus the square root of b, the conjugate is the square root of a plus the square root of b. Okay, so when we multiply by the conjugate, this is why we do it. If you took root a plus root b, and you multiplied it by root a minus root b, all of your roots would go away like this. Root a times root a would give you the square root of a squared, which is just a. Root a times root b, negative, gives you minus root ab. Root b times root a, positive, plus root ab. Positive times a negative gives me a negative. Root times root, I'm just going to end up there. Those cancel. So when you multiply by the conjugate, you just end up with a minus b, no square root. Okay, so that's the theory that we're working with. So if you're asked to rationalize this numerator, you've got the square root of x plus 4, and that 4 is inside that root, minus 2 all over x. Okay, so example A, rationalize the numerator. Okay, so when you rationalize the numerator, you take and you multiply this by the conjugate of the numerator. What's the conjugate? All you do is change the sign separating the two terms. Okay, and I chose this example on purpose because the only sign you change is this sign, not the one underneath the root. Okay, so it's a fraction. All you're allowed to do is multiply by 1. So what you did to the top, you've got to do the exact same thing to the bottom. So multiply the numerator and denominator by square root x plus 4 plus 2. Okay, so when we distribute this through the numerator, root x plus 4 times root x plus 4, this root times the root is going to just give you x plus 4. Root x plus 4 times positive 2, root x plus 4 times negative 2, the middle terms will cancel. You're just going to end up with the first term squared minus the second term squared. Like that. The denominator, we're trying to simplify. It isn't going to simplify. Therefore, just leave it in factored form. And now you can see that the top will simplify again. X plus 4 minus 4 leaves you with just x over x bracket root x plus 4 plus 2. Okay, here's why I didn't expand the denominator. You see, I have it in factored form. I have common factors. X goes into x once, into x once. My final answer, 1 over square root x plus 4 plus 2. Okay, so that's it for the lesson here. I'm going to stop presenting and turn off the recording and answer any questions that you guys might still have. And there's still 29 people here. Good for you guys. That was long. Okay, stop recording. Yes, I hope it